All right, so quick review of dilating a point with a certain scale factor and a certain center. All right, you guys are going to make up this problem here for me. So let's start right here. Jared, give me a point, please. Any point. 4, 6. Everyone graph it. 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, 6. Everyone call that point A for me, please. Call that point A. 4, 6. And now I need somebody to give me a center of dilation that's not the origin, please. Give me a center that's not the origin. Stellan?
2, 3.
Okay, everyone graph 2, 3 for me. 1, 2, 1, 2, 3. You guys can call that point O. There's the center of the that's the center we're dilating around. Okay, so we're going to take A, dilate it with the center at O, and I will give you the first scale factor of 2. All right, where's A prime going to be? Go ahead. Ooh, do we know what we're doing yet, huh? Do we know? Scale factor of 2, centered at O. Where's A prime going to move? Hopefully you're not putting A prime on the other side of O. It's got to stay on the same side. A and A prime should be on the same side of O. Find what that coordinate is, all right, so you can tell me if your number gets called. Tell me what A prime is going to be. All right, everyone got that new coordinate? Here we go. What's our new coordinate now? Stephanie, what's your new coordinate there? Okay, let's take a look. From O, because you have to start at the center. Up 3 over 2. So I got to go up 3 over 2. There's A prime. Let's see. 1, 2, 3, 4, 5, 6. Got it. 1, 2, 3, 4, 5, 6, 7, 8. Good job, Stephanie. Yep. All good. All right, next. Same center and going back to point A. All right, you're going to have to deal with little fractions now, but you guys can handle it. Let's go 1/2. Scale factor 1/2. Where's A prime now? All right, so go back to A. Center at O, but now I want to dilate it by 1/2. Dilate it by 1/2. All right, where's my new point? Lauren? What do you have? 3, 4. Okay, 3, 4.5. Let's see. Remember, I went up 3 over 2, cut it in half. So instead of going up 3, I go up 1.5. Instead of going over 2, I go over 1. So there's where A prime should have been. And we have 1, 2, 3. 1, 2, 3, 4.5. Good work. All right, any issues there? All right, I'm going to clear it now. New point. Give me a new point. We're going to call this one point B. Lauren again, point B. Your call.
2, 2.
Okay. 2, 2. Yep. I'll call that point B. I'm going to make the center of dilation. It's going to be the origin now, kids. All right. It's going to be the origin. Center of dilation is now the origin. And I'm going to make this difficult on you because you're going to run out of graph. I want a scale factor 6. Oh, he's only asked for 2 1/2. What do I do with 6? Well, you're centered around the origin, remember. I'm doing this on purpose. You can use your slope, that's fine, but I think you're going to run out of graph if you do. Try to do that 6 times, so you can still try it, but. Centered at the origin, point B is 2, 2. I want a scale factor of 6. It's going to get very far away. You can go up 2 over 2 6 times, right? Or you could do something else that we've talked about. That's why I put the center at the origin, right? All right, where are we looking at here? Tess? 12, 12. If the center's at the origin, you can multiply by the scale factor, remember. All right, that's why I did that on purpose. All right. Could I go up 2 over 2 6 times and end up at 12, 12? I could, but remember, you can also multiply by the scale factor. All right, any questions before we move on to today's last topic? So it sounds like you guys are pretty comfortable dilating points. Here's what I want to do today. Dilate a line. Okay, we're going to dilate a line. All right, well, first, let's talk about that. We know when we dilate, figures get bigger or smaller. I hate to break this to you guys, but lines can't do that. All right, so this first one here where it says a scale factor of 2, that line cannot get bigger. It goes on forever. Lines can't get bigger, and they're sure as heck not going to get smaller. They stay the same size. They go on forever. So what actually happens to my lines when I dilate it if it can't get bigger or smaller? First one up here, first scenario. Here's my center O. I want to dilate line AB with the scale factor of 2. Again, this line is not going to get bigger. All right, everyone understands that, right? Figures can get bigger, but lines can't because they go on forever. But what's going to happen to point A? What's going to happen to that point? Based on everything we've talked about with dilations the last 2 days. Scale factor of 2, what's going to happen to point A? Stellan?
Is he going to double its distance from B?
Not from B, but from, what's the center?
Oh.
From O, right? Right now, A and O are a certain distance. A prime is going to double that. Put A prime where you think it's going to be. Just be in the ballpark. Where's A prime going to be? Right? It's going to be double the distance away A is from O. So where's A prime going to be? Just put it somewhere. So, I'm sure many of you maybe put it like somewhere around here, right? Further away from O than A is. And guys, what's going to happen to B? Same thing, right? So put where you think B prime is going to be. And make a line now. Make line A prime, B prime. So put B prime where you think it's going to be. So let's talk now. The line doesn't get bigger, does it? No, but let's use a vocabulary term for me. What do you notice about the two lines? They're parallel, right? So when you dilate a line, it remains parallel to the original. All right, so A prime, B prime is parallel to line AB. When you dilate a line, the two remain parallel. Now, I know this is not on a graph, but when we do graph it, let's add something else in here with a new y-intercept. Okay, the y-intercept will change and the lines will remain parallel. That's what happens when you dilate. Sometimes that happens when you dilate. I got a different scenario over here for you. So we're all good. When you dilate, the line remains parallel. I'm going to have a new y-intercept. Sometimes. Here's the second scenario. Hey, where's point O now? I'm on fire. John Carleon. I do. You got it. Yep. All right, who's this going to be about? Again.
I've emailed her like 3 times that I just...
AirPods after... I'm just relaying the message. AirPods after class. Down in the ISS room. All right. You take care of your own business, so you don't have to interfere in my business. All right, back to my original question here. Where's 0.0 now? Oh, will it make a difference if the center of dilation is on the line? Will I end up with another line parallel? Let's find out. Well, I still have a scale factor of 2. Guys, what's going to happen to point A? It's still going to get further away, right? But where's A prime going to land? If I had you guys put where you think A prime is going to be, double the distance away that A is. Where are you going to put A prime? It's still going to be on that line, isn't it? You guys aren't going to put an A prime off it. You should be like, oh, it's going to double that, so it's got to be, I don't know, somewhere around here, but it's going to land on the same line. And where's B prime going to land? Double its distance away right now. Where's B prime going to land? On the line again. Probably after I extend it a little bit, right? Here's B prime. So is it always going to result in a line that's parallel? No. If the center of dilation is on the line, what can you tell me about my new line? Same line. All right, same line. So line A prime, B prime will be the same line as AB. All right, so if, again, go ahead, I'll let you copy that down and we'll review this. If the center of dilation is on the line I'm dilating, nothing happens. My new line is the same line. If it's off the line, my new line is parallel with the new y-intercept. All right, so it all depends on where the center is. All right, all depends on where the center is. All right, now let's get back to graphing. All right, I got line N, 3x plus 4y equals 20. We're going to dilate it by a third. Ooh, a third. We've never had really that before. And everyone sees the center, 4, 2. What's my equation of the new line? I, without a doubt, want you to graph this so we can see what it looks like on the graph, please. All right, let's see what this looks like. Now, hey, I wish I knew this when we were doing equations of lines way back, and I think it was unit 3 or 4. I'm just going to, some of you guys may want to put that in y equals form. You can use your calculator too, remember. All right, you can use your calculator. So whatever you want here, take a look. Quick review again. If you want to use your calculator, you can go to Grapher. You don't even need to get it into y equals form. You could just type it in, 3x plus 4. You guys know how to get the y. Alpha 3, where the y is, equals, not the pi, equals, what's it equal to here, 20? All right, take a look. Take a quick look here. Take a quick look. You can decide what you want to do here. So I have that. And then once you hit enter, you see how there's 3 dots over there? All right, if you want, you can go over there and then go to details. And it'll tell you what the slope and the, if you scroll down, the y-intercept is. I have it covered up. All right, negative 0.75, that's negative 3/4. The y-intercept is 5. Or heck, if you just want to graph it and look at the table and graph the points, I don't care how you get it done. All right, I'm not worried about if you can graph or not. I'm worried about dilating it. So find a way to graph it. That's what I'm telling you. Find a way. Whether you put it into y equals form yourself, use your table of values on your calculator, or you go to details here and find out the slope and y-intercept yourself. All right, get this thing graphed for me so we can dilate it. I'll make sure everyone's got a graph before we move on. Remember, everybody, it's a line, not a line segment. It's a line, not a line segment. Let's throw some arrows on that, please. Extend it a little bit. Okay, let everyone finish up. Get this graphed. You guys can start thinking about it here. I'm going to dilate by a scale factor of 1/3 around 4.2, it looks like. So maybe you guys can start looking at your line and seeing how this is going to work. All right, I'm going to move on. Now we're going to dilate it around 4.2. Oh, anybody look at your graph? What do you notice about 4.2? Oh, it's on the line. You're darn right. So guess where my new line's moving? Where's my new line going to go? Here you go, 4.2. It's on the line. This is line N, right? Where's my new line going? My dilated line. I don't care. I don't care if I give you a scale factor of 1/3 or 800. Where's my new line? It's the same line. All right, it's not moving anywhere. If your center of dilation is already on the line you're dilating, it's not going anywhere. So here we go. It wants an equation for line P. You got it. Here's line P. 3x plus 4y equal to 20. Same exact line. Explain your answer because the center of dilation is on the line. There you go. Are we clear on? We good? The only issue we're going to have if it's not on the line. All right, but if the center of dilation is on your line, it remains the same line. All right, let's talk about if it's not on the line then, and I got to actually come up with the equation. All right, number 2, we're going to take 3/2 x minus 4, dilate it by 3/4, centered at the origin. So go ahead, get an idea of what that line looks like. Again, you want to graph it using slope and y-intercept. You want to use your calculator. Get the job done, please. Get the job done. Correct. All right, let's finish up graphing. Looks good. All right, everyone ready to dilate this line by 3/4. Again, it's not getting smaller. Lines don't get smaller, but let's see if it's going to move or not. All right, is it going to move or is it going to remain the same line? Quick question for somebody. What's my center of dilation for this one? Center of dilation here. All right. Who's 18? Lily, I got. Why do I always do that? My eyes don't see it. What's the center of dilation? The origin. And last question for you, Lily, is that point on the line? No, so it's not going to remain the same line. It's going to move. And how's it going to move? Well, we talked earlier in the day here. At least we know when it moves, it's going to remain parallel to this one, which means what's going to stay the same? If two lines are parallel, what stays the same in our book here? Slope stays the same. All right, so what's the slope of this original line? 1/6, Bryson. What's the slope of the line you graphed? Look at the equation. It's in the equation.
3/2.
3/2. So that means the new line will also have a slope of 3/2. Everyone good? It's going to remain parallel, so the slope's going to change the same. The only thing we wrote is what? It's going to have a new y-intercept. So let's talk about how to find the new y-intercept, because you guys know how to find it. Well, what was the old y-intercept here? What was the old y-intercept, Lily? The line we're dilating, what was it? It was what? 0, -4, right? And we're dilating it with a scale factor of 3/4. What can I do with these two to find the new y-intercept? Multiply. Yeah, isn't that what we've been doing? When my center's at the origin, you can take the scale factor and multiply the coordinates by the scale factor. All right, so take the old y-intercept, multiply by the scale factor. What's my new y-intercept when you do that then? 0, -4 goes to where? 2, Simon?
-2.
0, -3. Yep. So there is my new y-intercept. -3. Point is off the line. It remains, slope stays the same, and you got to find your new y-intercept. If it's on the line, easy problem. It remains the same line. All right, 2 more here before we call it a day. This one, I don't have a graph. You don't have to graph it every time. All right, you have your calculators available. Dilation of 2 at 0,6 of this line, y = -3x + 6. I'm going to throw it on my calculator. Why don't you guys throw it on yours so you can see what we're looking at? Because I didn't ask you guys to graph it. So let's go back to Grapher. Y = -3x + 6. Boom. Let's see what this graph looks like. Boom. And it says our center of dilation 0,6. Look on this graph. What do you notice about 0,6? What do you notice about 0,6? It's on the line, isn't it? Right? So my center of dilation's on the line. What do you know about the dilated line? Oh, if the center of dilation is on the line, where's my dilated line going to go here? Where am I here? Finley? What's that? Same line, right? It's going to be the same line. So here you go. -3x + 6 is going to stay. -3x + 6. Are we all starting to maybe slightly figure that out? Hey, if my center of dilation's on the line, it's not moving. The only time it moves is if it's off the line. All right, what do we got? We got 2 more. Oh, we had 1 more left. All right. You guys can go ahead in your groups or by yourself. Go ahead. See what Aaliyah here, if she's right or not. She's going to take that line, dilate it by 2 around 3/4, and she says, there's my new line. Is she correct or not? Go ahead, figure it out. Okay, first thing, try to dilate it yourself by 2. But wait a second, we're dilating around a center of 3, 4. Where'd 3, 4 land? On the line. So we know after a lot of discussion today, here's where the new line should have been, right? 4x plus 3y equals 24. That should have been the answer. But hold off the brakes here on saying she's incorrect. How do you know that this isn't this just in y equals form? How can you tell? Before I say she's incorrect. Because she might be correct. She just didn't leave it in 4x plus 3y equals 24 form. Maybe she solved for y. How am I going to figure out if this is actually the same as that version? What do you got, Sully?
Put it into your grapher, and if you don't see like 2 lines.
You can graph it, and if they don't fall right on top of each other, it's not. What's the y-intercept here? 16. You have this thing graphed. What's the y-intercept over there? It's not 16. I think it's 8. So right away, I can tell that these aren't the same lines. They have different y-intercepts. Or like Stella said, graph both of them. And you'll know right away 2 different lines are graphed. So yes, she's incorrect. The image should have been the same line. Or something, it doesn't have to be that exact wording, but something that gets the point across is, hey, the answer should have been the original line. Any questions? Because I'm done with the lines. All right, last one. I just wanted to throw this one at you here. See what you can do with this one here. Okay, this isn't a line anymore. It's a line segment. So, hey, now we can get bigger and smaller, right? Not lines can't, but line segments certainly can get bigger or smaller. Here's A and B coordinates. Determine the length. What are we going to need here, kids? Yes! Distance formula. I love it. Find the length of the image after a dilation of 1/2 centered at the origin. I don't know. Can I have a plan before I start writing down some random stuff? There's actually 2 different plans you could have. What do you got?
You can find, first of all, you can find, just totally forgot what I was going to say.
Okay.
My bad.
All right, Lily?
Could you find the length of like the original and then divide it by 2?
I could use the distance formula on A and B, cut it in half, perfect. Or maybe some of you want to find A prime and B prime. Real quick, how can you find what A prime and B prime are? We've gone over this. Multiply by 1/2 because the center's at the origin, and then do the distance formula on those 2. Your call. Go. All right, you can find the distance of A and B, cut it in half, or find A prime, B prime by multiplying each coordinate by 1/2 and then do the distance. All right. Oh boy, do we need a distance again? So it just depends on what order you want to do it. Find the distance and cut it in half, or cut the coordinates in half and find the distance. Your call. Either way is going to get the same length.
Can I remove that one?
Sure.